Hi, welcome you all to the video tutorial on hypothesis testing. Hypothesis is usually considered as the principal instrument in research. Its main function is to suggest new experiments and observations. Many experiments are carried out deliberately with the object of testing hypothesis. The areas where direct knowledge of population parameter is rare, especially in the case of social science. Their hypothesis testing offer such support to make a generalized statement about the population parameters. Before we explain how hypotheses are tested, it is appropriate to explain clearly the meaning of hypothesis, the hypothesis characteristics, the concepts related to hypothesis, and finally we move on to the steps in hypothesis testing. So, what is hypothesis? So, when one talks about hypothesis, one simply means a mere assumption to be proved or disproved. But for a researcher, hypothesis is a formal question that he intends to resolve. So, what is a research hypothesis? A research hypothesis is a predictive statement capable of being tested by scientific methods that relates an independent variable to some dependent variable. For example, students who receive counseling will show a greater increase in creativity than students not receiving counseling. So, we can prove this statement with the help of hypothesis testing. We can say that hypothesis states what we are looking for, and it's a proposition which can be put to a test to determine its validity. In a nutshell, what I can say that hypotheses are the statement that needs to be checked. Moving on to the characteristics part, we have hypothesis should be clear and precise. If it is not so, then the inferences drawn from the hypothesis should not be reliable. Hypothesis should be capable of being tested. A hypothesis is testable if other deductions can be made from it, which it in turn can be confirmed or disproved by observation. So, you have an hypothesis that should be capable of being tested. Hypothesis should state a relationship between variables. So, if you have a relationship hypothesis, then you must state the relationship between those variables. It should be limited in scope and it must be specific. So researcher must take due care while specifying the scope of the statistic. The scope should be narrow because the narrow statistic should be tested, but the widest hypothesis it cannot be able to test. So it should be specific and the scope should be limited. It should be consistent with most known facts. So hypothesis should be designed in such a way that it should establish the facts also. Hypothesis should be amenable to testing within a reasonable time. So, its due care should be taken while designing a hypothesis. It should be not like to be an indefinite period. It should be finished within a stable period of time. Hypothesis must explain the facts that gave rise to the need for explanation. So, this means that the hypothesis, along with some known and accepted generalization, one should be able to deduct the original problem condition. Thus, hypothesis must actually explain what it claimed to explain. So, it should have some empirical reference. If we look at the basic concepts in hypothesis, so first we have the null hypothesis and alternative hypothesis. A statistical hypothesis, which is under test, is known as null hypothesis and represented by HO or H1. While on the contrary, the complementary to the null hypothesis is alternative hypothesis and it is represented by HA or H1. Level of significance. This is very important concept in the context of hypothesis testing. It is always some percentage, say 5% in by default, which should be chosen with utmost care, thought, and reason. For example, let us consider the level of significance to be 5%. What does this imply? It means that researcher takes a risk of rejecting null hypothesis by 5% when actually it is true. So the significance level is the maximum value of the probability of rejecting the null hypothesis when it is true and determined in advance before testing the hypothesis. In the context of hypothesis, we have two types of error, type 1 error or type 2 error. So we may reject HO when HO is true, or we may reject the null hypothesis when it in fact the null hypothesis is not true. So the former statement is known as the type 1 error, and the latter one is the type 2 error. So we can have a look over here. Here H naught is true, the null hypothesis is true, and we reject it. So it is an alpha error or the type 1 error. And when the null hypothesis is false and we accept it, then it is a beta error or the type 2 error. Moving further, we had a one-tailed test or two-tailed test. So a hypothesis test whose alternative hypothesis has the either form, the average values is less than the null hypothesis average value, or the less than or greater than sign. So we can say that it's a one-tailed hypothesis, either on the left tail or either on the right tail. So in one-tailed test, the rejection region lies either only on the left tail side or only on the right tail side, as we can see in the upcoming figure. Two-tailed test. A hypothesis test whose alternative hypothesis has the form of is not equal to is said to be two-tailed test. In two-tailed test, the rejection region lies on both of the side, on the left side as well as on the right side. So if we have the diagrammatically look, we can see that in the first part, the acceptance and the rejection region lies on the left cell itself. So it's a left tail test where all the value of the alpha lies on the left side, while on the right tail test, the value of the alpha lies on the rejection region lies on the right hand side. So it's a right tail test. In the case of the two tail test, the alpha value divides in two parts, two equal parts. Let's say for 5%, it will be divided into 2.5% on the left side and 2.5% on the right hand side, as it is shown in the figure. You can see over here 2.5% area on the left side and 2.5% area on the right hand side. So now comes to the main concepts, steps involved in the hypothesis testing. So to test hypothesis means to tell whether or not the hypothesis seems to be valid. So we need to check the statement. So in hypothesis testing, the main question is whether to accept the null hypothesis or not to accept the null hypothesis. So procedure for hypothesis testing refers to all those steps that we undertake for making a choice between the two actions, that is the rejection and the acceptance of the null hypothesis. So the first step is the formulation of the hypothesis, and it is an utmost important step because this is the where you have to accept and reject the hypothesis statement. So it must be accomplished with due care in accordance with the object and the nature of the problem and under the given circumstances. It also indicates whether we should use a one-tailed test or a two-tailed test. So when you set up your hypothesis, the next step is to define the level of significance. So as I've already mentioned that the alpha value has to define prior to compute the test. So in general, we have 5% level, but if we have some risky test, then we can use 1% or we can adopt 2% also. For instance, if we adopt 5% level of significance, it implies that in 5 out of 500 cases, so 5 out of 100 cases, we are likely to reject a correct hypothesis. In other words, it implies that we are 95% confident that our decision is correct. It should be remembered that the level of significance must be adequate in the context of the purpose and the nature of inquiry. In the third step, we have to define the appropriate test statistic. Before we try to define this test statistic, we must know that whether the test is the one-tailed test or a two-tailed test. So please be specific because in this part we in this one-tail or two-tail context, the alpha value should be divided either in alpha or in alpha by 2. We have alpha in the one-tail test and alpha by 2 in two-tail test. So in the next step, where we have to select an appropriate test statistics, it measures how close the sample has come to the null hypothesis. So the test statistic often follows a well-known distribution, such as the normal Z distribution. We have T distribution, we have F distribution, or we have chi-square distribution. So these are the common distribution we use to apply the test. We use Z distribution when we have large sample to be used, and we have a small sample as the data collection, so we apply the t distribution. And if we are using the comparing the two variances, then we use the f distribution. And if we use the goodness of fit test, or we use the test for independence, we use the chi-square distribution. So once you decide which test has to be applied, you have to collect the data and compute the test statistic value. So in this step, you have to find out the uh, test statistic value, and the calculation of the standard error to testing statistic is very important, for which we can apply the different formulae. So now, till this step, we have defined the test statistic, we have calculated the test statistic value. Now we will have to determine the critical value of the test statistic at a given level of significance that we have already specified in step number 2. So this value is obtained from the specified tables at the level of significance specified in step number 2. So it can be easily seen on the table side. So let's say, for an example, if we have 5% level of significance, then the Z table, the normal distribution table, will have the value in between 1.64 and 1.65, that is 1.645. So it can easily be seen on the table itself. So once to determine the value of the alpha and test statistic alpha and the compute value of the test statistic alpha, so we have to compare these two values we have obtained in step number 4 and 5. So we can compute the test statistic computed value should be greater than, or it is less than, with the test statistic alpha value. So if it is so, if the test statistic compute value is more than the alpha value, then we reject the null hypothesis. And if it is not so, then we do not reject, or we can say that we fail to reject the null hypothesis. And on the basis of this, we can draw our conclusion, or we can make the interpretation. And the interpretation is what is the statement written on the null hypothesis part. Like as I take the example of the Maruti, then the statement that the Maruti new car has an average more than 17 kilometer is the null hypothesis. And if we reject the null hypothesis, then we can say that the claim, whatsoever the manager claims, is not correct. And if we fail to reject, we say that whatsoever manager is claiming is correct. So this is all about we have the conclusion of the interpretation we will make with the help of the hypothesis testing approach. This is all about the steps involved in the hypothesis testing. Due care must be taken while using all these steps, because one's job should be at stake if we take the wrong decision. It means that if we commit the beta error or the type 2 error, then the job of the marketing manager will be at stake. So thank you very much and have a nice day.